In this video, I introduce a graph retrieval for chatting with a textual graph. Graph retrieval is a question answering framework with a textual graph, which integrates a graph neural network, large language model, and retrieval augmented generation in 4 steps, namely indexing, retrieval, subgraph construction, and generation. A textual graph G defines a set of nodes V and edges E as shown here, with textual attributes xn and xe respectively. Indexing step uses a pre-trained large language model to encode the text attribute associated with the nodes and edges. For a node n with a text attribute xn, the encoded attribute zn is computed by using language model. The same language model is applied to a query xe. The encoded query is computed by using language model, where ze has the same dimensions as zn. Retrieval step uses key nearest neighbors retrieval approach to find the most relevant nodes and edges with the current query through these two equations. Whereas the cosine similarity is used to measure distance between query and nodes or edges. Subgraph construction step constructs a subgraph that encompasses nodes and edges relevant to the query. Price collecting Steiner tree is used to find a connected subgraph that maximizes the total node price while minimizing cost of the total edges. The node assignment is defined as here. Edge prices are assigned similarly. The objective is to find a subgraph S star that maximizes the total price, which is defined as here, where cost S is defined by ES and CE, where CE denotes a predefined cost per edge to control subgraph size. Graph encoder is used to model the structure of a graph using graph attention network here, where pull function denotes the mean pooling operation. Multi-layer projection aligns the graph talking with the vector space of a large language model, as shown here, where the dimension of the large language model's hidden embedding is DL. Text embedder transfers the retrieved subgraph as a star into a textual format, and the textualize function flattens the textual attributes of the nodes and edges. The concatenation of textualized graph and query Q is mapped to embedding HT using a text embedder, as shown here and here. Generation step generates the answer Y given the graph talking and textual embedder output. The probability of answer Y is computed by using this formulation, where R is the number of output tokens. This is the concatenation of HG hat and HT for soft proper tuning. During training, G retriever updates the graph encoder phi 1 and the projection layer plateau through backpropagation. Well, the parameters theta in large language model are frozen. For more details, please check with these references. Thank you. Bye.